Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we are going to talk about the Hayabusa spacecraft and how it helped improve our understanding of our solar system. So, the Hayabusa spacecraft was launched on May 9th of 2003 by the Japanese Space Agency, and it was a proposed sample return mission to actually return material from space to Earth. Now, we've seen that there's been occasions for sample returns from the moon, including the Apollo missions, and we've also seen other sample return missions to collect particles from the solar wind. This was the first attempt to try to get any material from an object other than our moon or from out in space directly. So its purpose was to collect samples from an asteroid known as Itokawa, and it was going to land on the asteroid and return the material to Earth. Now, in reality, it wasn't supposed to actually land. The idea was that it would come down right to the surface and just collect a small amount of material and then return that material to Earth. However, the first attempt, there were some issues with that, and it ended up spending about 30 minutes on the surface. So, being the first spacecraft to ever actually land on an asteroid, even if that wasn't really the plan. Now, what were we able to learn from this? Well, the mission was successful and did return a tiny amount of material, maybe about a gram or less. And that's not a whole lot, but of course it was still material from the early history of our solar system, and that's why we like to study asteroids. And this was the first detailed study we ever had of what is called a primitive asteroid. Primitive in this sense means that it is unchanged since the origin of our solar system. So when our solar system formed, these were some of the first objects to form early on. And many objects like this then became part of Earth. Now we can take a look here at what this would have looked like. And here is actually an image of Itokawa as imaged by the Hayabusa spacecraft. And it was very interesting in that we found that not only was the very primitive, but the composition is similar to meteorites that we find here on Earth. So, the same types of material, and this would have been lots of these, in fact, billions upon billions of these would have been what built up Earth over time. Now we notice that it's a very unusual shape. Lots of the objects we look at tend to be spherical, and that's because larger objects will pull themselves into a sphere because of their gravity. Smaller objects like this asteroid do not have a strong enough gravity to be able to do that, and therefore they can be very odd shapes, and here we have a very elongated asteroid. Now, one of the very interesting findings in these small particles that were detected was the presence of water particles. Now, it's thought maybe that water came to Earth from asteroids and comets like this. So the more water we find there, the more that kind of helps that hypothesis that maybe that's where the water on Earth came from. Because with Earth's location in the solar system, there shouldn't be a whole lot of water here on Earth. We're closer to the sun, it's a lot warmer, we wouldn't expect large amounts of ice. But maybe other materials came in from the outer solar system early on, giving the Earth more water than we would have expected. Now, as I noted, the big thing with this was that this was the first return of an asteroid sample to Earth, returning to Earth on June 13th of 2010. So let's go ahead and finish up with our summary. And what we've looked at today was the Hayabusa spacecraft, launched to collect a sample of an asteroid and return that sample to Earth. We would hopefully from that learn more about the composition of asteroids, and it really set the stage for future return missions that we will look at in future videos. So that concludes this discussion of the Hayabusa spacecraft. We'll be back again next week for another exploration of the solar system video. So until then, have a great day everyone, and I will see you in class.